Okay, so in this prac, this is the prac on two-sample t-test and match pairs t-test. So let's have a look at what we're going to do. We're over here, we're going to read in the Bechdel data, then we're going to produce some plots to compare the distributions, then two-sample t-test, QQ plots, and a confidence interval. That's pretty good. And then with the match pairs, this time we've got beans, download it, no problem. Match pairs, and we're going to have to compute the differences and QQ plots. Cool. Well, let's start. Here's my SPSS. Here's my two data sets, Bechdel and beans. We'll start with the Bechdel. So we need to open this. So let me find desktop. Let me find Excel, Bechdel, open. That all looks good. It's loading in, and we seem to have, we've got the Bechdel and the profit, which is what we're going to look at. We've also got the title and the year in case you want to investigate further. So the first thing it says is some plots to compare distributions. Well, to compare distributions, we're going to need the shape, location, spread, outliers. Now shape is histograms is the best way of doing it, back to back. Well, the rest I reckon side by side box plots. So as always, graphs, chart builder. Don't need to see that dialogue again. Right. So first of all I said histogram, so choose histogram, back to back. Now the distribution variable is going to be profit, and we're going to split on Bechdel. Click OK. Cool. Now that's quite an amazing little plot, isn't it? You can see that we have both cases. We've got lots of points pointing to this really high profit. If you're interested, go and have a look at what them high profits are. Basically, both of these are very right skewed. So we've definitely got right skewed data, and that means that normalities might be a problem. We'll still go and do the t-test, but we probably would want to look at something different. Now, let's have a look at the graphs, chart builder. This time we're going to do box plots. Our y-axis again is going to be profit, but we're going to put Bechdel in here. Click OK. And wow, again, we're getting huge lots of outliers. Look at all these outliers here. Very, very right skewed. Some very extreme. This 159 that passed. I'm just dying to know what that is. Let's see if we can quickly find out what 159 is. 159, the devil inside. That is huge profits. Devil inside, horror movie, which sort of makes sense. Horror movies, very cheap to do, often unnamed actors. Yeah, that's pretty cool. Anyway, that's not what we want to do. We'll now do a two-sample t-test. So, analyze, compare means, because that's what we're doing, and we want the independent samples t-test. So, again, the thing that we're interested in is the profit, and the grouping variable is our Bechdel. Notice we've got question marks. We've got to be careful. We have to let it know. I'm just going to move this over before we click on that button. Notice I have pass and fail both in uppercase. So click define groups. Group 1 I will call pass and fail. And notice they have to match what's in here. Click continue. That's all looking good. Do I need anything else? No, I think that's good. Click OK. So here's our output. Here is the mean profit for those that pass, the mean profit for those that fail. Big difference it looks like. Standard deviation quite varied. So here's our two-sample t-test, the main thing that we want. Notice there are two rows. This top one, where we're going to assume the same variance, is not the one we do in this course. It's called a pooled sample t-test. We don't do that. We always go to the second one. Here's the second one, not assumed. There is your test statistic, your degrees of freedom, your p-value, and as well, here's our confidence interval as well. Don't need to do anything, I can read that directly off. Unlike, remember, with a one sample t-test, you have to faff around with this. In this case, you don't, which is nice. Now, QQ plot. So we need a QQ plot. Now, there's a little bit of a trick to this. You're going to go analyze and explore. So descriptives, explore. We put again profit in the dependent, vector in the factor. Now if we click plots, normality plot with tests, it's perfect, that's just what we want. Continue, okay. And all the way down, there you are, there are the two plots. Here's the first plot for all the movies that fail the vector. Notice how curved that is compared with that line. And it's definitely not normal data. And again, here is for all the movies that pass. We've got a real curvature. So in both cases, normality is not appropriate. But we can probably get away with it. Think about a theorem that would help us get away with that. Think about a theorem that tells us that even though the data is not normally distributed, the sample means are probably normally distributed. Cool. So now, let's go and get some more data. This time I'm going to do beans. So again, I'll go to my desktop. Choose, moment, cancel. It thinks I want output. What I really want is data. So again, Excel, beans, open. Okay. So here we've got 15 students. The number of beans they count with their dominant hand and none with the non-dominant. So the first thing we're going to do is a match pairs test. So analyze, compare means, and there is a pairs sample t-test. Perfect. Cool. So we want dominant in there and non-dominant in there. You see it automatically puts it in for you. All done. Don't need anything but that, and we click OK. So here we are. Here is our match pairs t-test. So there's the mean of the differences. There's the standard deviation of the differences. Here is your confidence interval, your test statistic, your degrees of freedom, and your p-value. Everything to do what you need. The assumption of this is, well, first what independence, that is with one people counting their beans, the difference in their beans affects someone else. Well, if they're doing it at the same time, maybe they have a competition, maybe it does have an effect. But if they're doing it separately, no, it probably doesn't. Also need normality, but we need normality of the differences. We don't have that yet. We need to go and calculate the differences. So if we go transform compute. So we're going to call this new thing differences, no problem. And what its difference is going to be, it's going to be the dominant minus the non-dominant. So this basically says, I want you to compute a new variable. So there'll be a new column in our table called differences. It's going to be created by taking the dominant from the non-dominant. So click OK. Now, has that worked? Well, we've got to look at our data. Yes, it has. Let's check. If you take dominant minus non-dominant, 22 minus 18 is 4. 19 minus 50, yep, perfect. Now we have the differences. Well, easy. We now have to do this. Analyze descriptives, QQ plot. Put the differences in there. All looking good. Click OK. And there you are. Not bad. Line pretty close to that line. A little bit wobbly. You got this point here and this point here, but let's face it. You know, this is a very small data set. So, all done. And that's it. I will stop there.